Well, good afternoon, everyone, and welcome to the last session of what's been a fantastic 3 days. And it's been my absolute pleasure to chair the next 45 minutes or so. We've got two great speakers. We've got Axel Bender, who's going to give a special presentation on the human and the contested environment. Axel is the Starshot leader operating in a contested environment, and he'll explain his title, no doubt, to you. And we'll take some questions after Axel's talk. And then after that, we'll close off with Dr. Nick Beagley, who'll end the proceedings. But with no more delay, I'll just pass you to Axel. Thank you.
Thank you, David. Firstly, I'd like to thank Dave and the team for the invitation to DHSS and the opportunity to talk about the human in contested environments, and especially about Starshots, where STAR stands for Science, Technology and Research. Arguably, being a warfighter is the hardest of possible tasks. But if you click on, I have bad news because, next slide, the future looks even worse for the warfighter, because the future will be more complex, more uncertain, and more dangerous. It will be more complex because not only is there any more separations of the classical domains of land, air, maritime, but you'll find that a warfighter now has to work across these three domains, but also has to get strategic information and control actions through space, has to be aware of the cyber environment as well as the electromagnetic spectrum. All of this makes things much more complicated and complex. In addition, the future battle space will be more crowded. Not only will there be humans, but we expect that there's a massive increase in robotic and autonomous entities, such as uninhabited ground, air, and undersea vehicles. And the future warfighter has to be able to constantly and rapidly adapt to changing circumstances in a much faster way than in the past. This is, for instance, why Army have released their new strategy around rapidly changing Army. The environment will also be more uncertain because technology allows adversaries to deceive better, to misinform, to disinform, which will increase the warfighters or degrade the warfighters' situation awareness or information certainties. I would also expect that there will be an increase in dilemmas, especially ethical dilemmas, for instance, through an increase in asymmetric threats, such as adversaries hiding in crowds of civilians, and where you need to then make judgments about who is on the bad side and who is on the good side. The more dangerous aspect of the future, I mention here particularly increase in what I call silent or invisible threats, such as chemical, biological, or radiological threats. But another thing would be, for instance, that what traditionally was direct fire, 300 meters, now well exceeds 5 kilometers, and that means it is outside what humans can perceive with their own senses. Apart from that, unfortunately, our warfighter will be hit faster because speed of weapons increases, and you can expect that weapons that are launched from many kilometers away can precisely target our warfighter. So this is why the future is more dangerous, more uncertain, and more complex. If you click on next slide, I mean, what is understood is that because of this increase in complexity, uncertainty, and danger, there's an urgent need for more and for new science and technology. And that is the reason, or one of the main reasons, why Defense has launched in May its new Defense Science and Technology Strategy, More Together. Next slide, please. More Together articulates that we like in the future, over the next 10 years, focus more on big, large science and technology programs that are strongly aligned with defense strategic priorities, that we can't do that alone within defense, but that we have to generate scale through an unprecedented partnering with the national science and technology ecosystem, as well as with our partners in international communities, and that we need to use science technology for the generation of impact through delivering a capability edge to the future warfighter. If you click at the next slide, at the core of this More Together science technology strategy are starshots, where, as indicated, STAR stands for Science, Technology and Research. Starshots are mission-driven strategic defense research and development priorities. These are topics that defense as a whole has selected and has articulated. This is where we want to focus our science and technology resource in an unprecedented way. They are ambitious, or I might even say some of them are audacious with regard to what they try to achieve. Current science and technology cannot achieve the objectives and goals that are articulated in these starshots. They are there to mobilize effort and collaborations within the domestic S&T ecosystem, as well as with international partners. And all starshots have at their core an articulation that there will be pathways from concepts and ideas to capability so that impact can be generated. What you can see in this graphic, for those of you who have larger screens than I do, there's currently 8 starshots that have been formulated. Information warfare, disruptive weapon effects, quantum assured positioning, navigation, timing, battle-ready platforms, agile command and control, resilient multi-mission space, remote undersea surveillance, and the one that I am representing, operating in chemical, biological, radiological, and nuclear environments. If you click on the next slide, an important part of the starshot is the centerpiece. It is about prevailing in contested environments. And there's a full understanding that this is not just about improving or enhancing technology, but that this prevailing in contested environments has to be with the human in mind and has to be building the kind of human technology interactions and teaming concepts and technologies that allow for better survival and higher effectiveness and higher performance in contested environments. If you go to the next slide, I might just now focus a little bit on one specific starshot, namely the one that I have the pleasure to lead. Operating in chemical, biological, radiological, and nuclear environments is about enabling the joint force to operate safely and effectively in CBA and threat environments. These are the most demanding environments that you can imagine. We are imagining that our warfighters know that there's a possibilities for these threats to be launched against them. And it means there's a higher cognitive demand. The equipment that we normally use to operate in these environments put a lot of physiological and physical burden, as well as cognitive burden, on the individual. The reason why we are very interested in this particular starshot is because there is an increased likelihood that these threats will be present in the future operating environment. We have seen in the past decade that our possible adversaries use these weapons despite the various conventions and treaties that actually disallows their use. And the other worrying trend is that it is easier to manufacture many of the threats that we are interested in this starship. What we like to achieve, though, is through the progressive development and demonstration of novel technologies, that we are able to generate leap ahead capability for these operations in seaborne environments. Next slide, please. So what defense articulated as broadly the requirements for operating seaborne environment is about the core pillars of CBRN defense. Firstly, we need better ways of detecting, identifying, monitoring those threats. Secondly, we need to improve significantly the way we predict, warn, and report these threats. And this means near real-time warning, the integration of our systems across the joint domain, but also with coalition partners and with the civilian world. That means that because these threats do not differentiate between military and civilian humans, we need to be able to warn civilians as much as we do military. The third core piece is about increasing significantly our protection against chemical, biological, radiological, and nuclear threats in a way that the operations for our warfighters is not disrupted, or if disrupted, only minimally disrupted. This is not the case at the moment. If we are expecting that we're moving, for instance, into a chemical plume, our soldiers don a MOP 4 suit that is highly restrictive in their movement, puts a lot of strain on their body, and only protects for a very short period of time before actually it has to be replenished, for instance, with filters. The last area is that of effective containment and decontamination. I might just remind you of the Salisbury poisoning that happened a bit over 2 years ago, which paralyzed the whole city in England for many weeks. And this was caused by just a few drops of a chemical agent that is hard to detect, hard to remove. And when I talk, apart from killing people, which is a very, very tragic event, the ramification for the city of Salisbury was enormous, and the costs of cleanup were equally enormous, which are estimated to lie in the order of $50 million. So what we need, therefore, especially for this symposium, is novel ways of interfacing and teaming between humans and machine, because in the future we require technologies that support the human cognitively, physically, physiologically, and that will include autonomous systems as well as decision support. We need more resilience in the human, and that cuts across physical, physiological, cognitive dimensions. We need to improve, enhance our selection, training, performance capabilities for the warfighter. So new ways of selecting, training, and preparing, new ways of measuring and monitoring human health and performance. And that means creating new data sets, new ways of collecting data, new ways of interpreting and analyzing data. Next slide, please. So the way the Starship likes to go about this is through agile and spiral development processes, where we develop and demonstrate several high-value, integrated, minimal marketable products that represent leap ahead seaborne defense capability. What you see there in this graph is some component technology along the horizontal axis, such as new sensors or new sequencing capabilities or autonomous systems or decision support systems or technologies that enhance human resilience. But what we want to do is these gray areas, we want to integrate across those capabilities to actually generate systems that use all of these technologies for a big capability impact, such as significantly enhanced threat awareness and warning, or significantly enhanced integrated protection against chemical, biological, and radiological threats. So what we see us doing in this starshot is that we will seed research and development in high risk, high payoff component technology. So there will be some demands on new sensors, there will be some demands on new biological sequencing technologies, on decision support systems, where we need to make targeted investment to advance some gaps very, very rapidly. The other bit that we do is we need to build from the start a capability that is where we have interoperability and integration by design, so that we are able to, in a spiral development process, show continuously increased capability and are able to frequently demonstrate this increased capability to the user, so that we have a closed loop between the technologists, innovators, researchers, and their developments, as well as the users in terms of the evaluating of utility and advancing capability from an end user's perspective. Next slide. So I'd like to pretty much end by giving you a couple or few challenges here that you might want to think about. What we really need is faster detection and also characterizations of especially of chemical and biological threats. I'm quoting here Galileo Galilei: measure what can be measured and make measurable what cannot be measured. So there's already a lot of technology out there, and you have talked about wearables and some of those advancements over the last 3 days. But if we want to understand or make, let's say, find the effects or find pathogens early, we might need to also make measurable what cannot be measured at the moment. For instance, a paradigm shift may well be that the starship pursues around what is actually a chemical, biological, and radiological sensor. Currently, we're thinking very much specific sensors, spectroscopy, colorimetry, etc., to maybe something where everything can be a sensor. Human behavior can be a sensor. Animal behavior or health status can be sensors that might give us an indication of a pathogen in an environment. A second core challenge for this forum here is that around increased human resilience. I think a lot of the presentations over the few days were around cognitive and physical performance, how we can better measure it, how we can also enhance it through a range of interventions. So I'm very curious and interested in engaging in discussions around those measures. I'm also advocating that there is a whole range of new protection possibilities and increasing resistance and invulnerability of humans. For instance, when we not just look from the skin out, where we put equipment around of a human, but also thinking about how can we protect and make more resistant and make invulnerable people from the skin in. Lastly, I mean, it is about also enhancing warfighter equipment. There needs to be more human-centric designs. I'm not too sure whether our current way of putting people into Mod 4 suits is actually built around human-centric design. That's probably an interesting discussion to have. But we need to also think about how we supplement and augment and support the humans in these environments, not just through physical equipment, but also through exploiting in the right way the emerging technologies around Internet of Things, artificial intelligence, machine learning, to actually generate really clever decision support system, training systems, and the like. This is pretty much everything I wanted to talk to you about today. I'm very curious in the discussion because enhancing human performance and human health in these contested environments is enormously important to us in defense. So I'm looking forward to the coming discussion, and thank you all for your attention.
Thanks very much, Axel. You've provided a somewhat sobering view of the future, but yet you've also provided a way forward and identify the challenges, which is an optimistic way of helping us as a community to work towards delivering on those star shots, which is absolutely fantastic. Now, I've been inundated with questions, and I've got one straight away that speaks to both the role of humans and the role of autonomous vehicles. So the question is, given the increasing threat, perhaps the focus might be on keeping soldiers out of harm's way. What role do you see autonomous systems playing in the future operating environment?
I mean, they already play some role, especially in the CBRN environment. I mean, and I would definitely, I have articulated that the star shot, that the best way of protecting and ensuring the survival of people is to have them not there in the first place. So autonomy will play a role. Having said that, this is about operating in CBRN environments. So this is not just about the CBRN threat. So we have to imagine that warfighters do their tasks, like humanitarian assistance, disaster relief, or non-combatant evacuation. So they have, so these tasks are enormously complex, and I can't see that autonomy would be able to do all of this, because what we are asking then is replacing all the humans, everything around a warfighter's roles with autonomous. So I think the way forward is yes to autonomy, but autonomy as a team member, as a supporter, as an augmenter of the human, rather than as a replacer. There will be some dirty, dangerous, dull tasks as well, that we can do really just with machines, but I would imagine that that will be only a very small proportion of the tasks.
Thank you for that. Not surprisingly, given the forum that we have a number of questions that really speak to the question of partnership and how to work with defence. And I suppose one of the first questions is, you talk about a future where we have an agile and constantly changing environment. How can academia, industry, and perhaps even parts of defence keep up?
Well, I mean, so all starshots are currently defining their problem space more accurately. So most of us are in the so-called formation space, where we are engaging extensively across defense, the different services and the different groups to get really as accurate as possible problem definitions. The intent is to share these problem definitions with the wider community, to set some big challenges, and also to, let's say, inspire or make the ecosystem think about some of those, because there's really some hairy challenges in there that require really new kinds of research and new kinds of innovation. There's, in parallel, we're building better ways of engaging, so to become more agile. So there is, I mean, I'm not sure whether you have talked about this throughout this symposium, but Minister for Defense has just recently released Defense's reform strategy, Lead the Way. I think that was just a couple of weeks ago, which articulates that we as a defense department have to become more agile, and that will pervade the way we will interact. So DST Group, who are currently driving a lot of the star shots. Yeah, we want to build communities of practice, different ways of allowing for multi-university, multi-sector collaborations to occur, so that we actually get the best out of the national S&T enterprise. Not sure whether that answered the question, but that's for the moment what I articulate. But if you have specifics, we have a website, where all Starshots, you can directly contact Starshots. In my Starshots, we will generate a mailing list. So just let us know if you want to be on a mailing list to keep you informed on Starshots. Our organization is currently putting together an engagement and communication strategy that we will share. So there's a lot happening in the background around Starshots and how Starshots will actually in the future engage with everybody.
And on the question sort of partnerships and working with defence on Starshots, we've had a number of participants in the seminar the last couple of days that have come from perhaps the UK in particular, and the US and some of the other allied areas. And I just wonder what the scope is for collaboration at that level, and how does that work?
International partnerships are enormously important to us. I mean, especially the Starshot that I'm representing, I think there's a vast amount of work to do. I can't see this occurring without international collaborations and without being really collaborative and not duplicating effort. The CBRN community is surprisingly collaborative anyway, definitely across the Five Eyes. So we are already tapping in some of our existing partnerships, such as a memorandum of understanding on CBRN, that deals with counter-proliferation, etc. But we will establish other partnership across, especially the Five Eyes. So that's United States, Canada, UK, and New Zealand, and Australia. But we are also interested. I mean, we have started collaborating with Japan and Korea in this space, and then we are open therefore to any partnership that can advance this quest for enhancing our warfighters' chances to survive and operate successfully in these environments.
Okay, and we're just getting close to the end now, but one last question, which really speaks to a much broader interaction between governments and citizens, given that we've just and experiencing currently this enormous upheaval with COVID-19. How is it important? So perhaps how important is the reaction of governments and civilian populations to working together to face together these challenges, and what lessons can defence learn from the variety of responses that we've seen, perhaps, that will allow us to face CBRN threats potentially in the future? What learnings have we got out that you might be able to identify?
I mean, with only a couple of, this is a very big question.
It is.
I think from that perspective, for me, it indicates that defense is only one of the many stakeholders in this space. This is a much bigger problem domain, and it is a challenge for the whole nation or for the whole research community. It's not just to treat biological threats as a defense issue, but also from the public health perspective, as well as from other perspectives, economic. So I see there is a definite need, but a great opportunity now to pool resources and actually as a nation, to come up with really good science, good technology, good innovation, and better response strategies for these kind of challenges. I think we are lucky at the moment in Australia with COVID-19, how we responded, but ultimately, there's a lot to learn in terms of how we can improve our general stance to this, our strategic responses, but then also a lot of need for new technologies and new concepts in how we deal with this. So I think the answer is really yeah, we are all in this together. Defense is just one of the players in this space, and it is about collaborating across. I have definitely the intent, yeah, to look at this not just from a defense perspective, but from a national health perspective as well, and take that opportunity to, yeah, instill really much more than just a defense benefit, but also a benefit for the community out of this.
Thanks, Axel. I think we could, talk about these things for hours to come, and I know you and I can do that, but I'm not sure if the audience can and our participants can. But look, I just want to thank you very much indeed for providing us with the view of the more general question of strategy at defence, but also an insight into your own particular Starshot and the role that humans have in that sort of contested environment. So thank you very much indeed, Axel.
Yeah,
I invite you
thank you, and I might
stay on as well.
I invite you to
quickly stay on
that
so
people
that
can send me emails if they.
Sorry, you're muted.
Okay.
So I invite you to stay on, and we'll just pass to Nick to close the seminar. Nick.
All right, thank you, David. Okay, so look, it's a real privilege to be able to draw this event to a close. I'd also like to thank Axel, who's been a major champion for the human sciences within his Starshot. So it's good to have that leadership. But look, when it comes to this event, I'm sure many of you have been involved in running symposia and conferences, and you just know you're always on edge. And that would be particularly heightened, I'd say, given the uncertainty of how we're running these things. This virtual delivery, it was a real unknown. We didn't really know how this was going to go. And I can say to all the organizers, you can breathe again. Well done. It's been a great success. We've just had a whole raft of fascinating and really relevant talks. And great, really meaningful audience engagement. It was really uncertain as to how well people would be connected and whether they would join in. But attending all these sessions, there was a range of questions as long as your arm for most of these, and it really was strengthened by the chat function here. So in traditional conferences and symposia, you'd have one or two questions, but you had all of these others that were still being answered afterwards on the chat function. So if anything, I think that this call to try to build from our experience that I challenged you with at the start of the conference, you've definitely risen to that, and it's been very impressive, and I've been really pleased with how engaged everyone is. And in terms of attendance, we've had over 280 registered attendees. That's really impressive. I know not everyone was engaged all the way along. That would be an unreasonable expectation, but it is impressive nonetheless. It broadens the reach for our community and allows more to dip in and out for those bits that are of particular relevance to them. And when you look at the people who did participate, 25% were defense, and that includes DST. And that's quite a change from the DST of old, DSTO of old, which was a predominantly DSTO grouping, whereas now we've got 70% university participation, only 5% industry, but I think we will see those numbers grow over time. But that's a wonderful mix that really demonstrates the breadth of our community. And we've also had great participation from across Australia, and also internationally, despite the time zone challenges that come. So thank you to particularly those sort of UK and US members who have joined, despite those time zone challenges. And it has been a really rich program. But look, I won't play favorites. That's what the awards are for, and we will get to that in due course. So what I'd like to do, though, is just say a few thank yous here, and I'll start with the organising committee. So David Crone, Chris Best, Phil Temby, Sam Huff, Stephen Talbot and Susan Cashel. That's our organizing committee. Thank you so much for your efforts here. These things don't just happen. And I'd also particularly like to ask to thank our deacon hosts here. So Professor Owens, Con Mouzakis, Luana Main, Jodie Morgan, Georgina Fatris, Tara Stenhouse, Claire Hazelwood, and David George. So that's, you know, just shows you how many people it takes to pull off something like this. And it was wonderful having that collection of moderators from both DST and from Deakin. So thanks to Con, thanks to Con Mouzakis, thanks to Simon Parker and Spencer Roberts. Thank you, Chris Best and Sam Huff and Susanna Whitney. And I'm sorry if I've left any of the names off there. So maybe if we'd all pretend that we can turn off our mutes and we'll just applaud. So well done, everyone. All right. Well, we'll let the applause die away, and then we will move on. Goodness, they really are impressed with you. Okay. So what I'll do now, actually, is take us to the all-important awards ceremony. So if I can play that now, there we go. So if you can see the audience behind me, okay. I would like to then reach for the awards envelope. So here it is. Drum roll, please. All right, so the best talk award. So the best standard oral. So this is the gold standard, and the winner is Jamie Tate from Deakin for recovery of cognitive performance following multi-stressor military training. Okay, moving on to the best mini oral, and that is to Alex Chapman from the University of South Australia for measuring real-time cognitive load in naturalistic environments, initial pilot results from EEG systems worn under a military helmet. Well done, Alex. Okay, and we have introduced a third special award this year in honor of our new way of meeting. And any of you who have been tracking the leaderboard will be on tenterhooks with this one. So this is the Hoover App Award for Community Interaction. And it was really hard fought. So I'd like to provide honorable mention for, so our bronze award winner on this is Martin Imnick from the University of South Australia. So well done, Martin. And drum roll, please, because these two really fought tooth and nail all the way through. And I think all of us are better off for that competition. Neither took a step back. Both are fiercely competitive and put their heart and soul into that. So real congratulations to both of these individuals, but there has to be a winner. The second place for the App Award is Dr. Eugene Aidman. All right, which means our winner is Dr. Katie Tooley. So well done, Katie. Well done indeed. All right, well, that concludes our awards section, but I couldn't miss the opportunity for putting a plug in for the events that happen from here. So many of you who have spoken over the last few days are also going to be participating in the HIPAANET Symposium, which kicks off tomorrow morning and continues on to Friday morning. And also I'd like to put a plug in there for the Undersea Decision Superiority Network Symposium, which follows the HIPAANET Symposium on the Friday afternoon. So please do come along for that. So with that, it really just falls to me to say we're looking forward to doing this face-to-face, and maybe bringing along some of these technological tools that we've become masters of over our lockdown period. But I, for one, am certainly looking forward to the other opportunities that come from being in the same room with all of you. So looking forward to 2021. Thank you so much. This is really, it's about the people who participate, and you have all come along and actively participated and made this a true success. So looking to 2021, thank you so much for your participation. And with that, I'd like to call this year's Defence Human Sciences Symposium to a close. Thank you.
Thanks very much, Nick. That's fantastic. Can I just get Jody, Georgina, Tara and David to show their faces, because I'm not sure if anyone has actually seen them. So these are the people that were behind, and just want to say thank you, and just reiterate Nick's great thanks, because it's not just about today, but it was about the weeks of meetings that we've had to ensure that this, and you've all been very, very supportive and helpful. So thank you all from me. Thank you.
Thank you.
Thank you.
Thanks,
very
Nick. Okay.
much. Thank you.